Now let's continue our crash course for AWS Solution Architect Associate by going into databases. So welcome to this overview of Amazon Relational Database Service, RDS, a managed service within AWS that simplifies the provisioning, creation and scaling of relational databases with RDS. Mundane administrative tasks like backups and patching are managed by AWS, allowing you to focus on your applications. Amazon RDS offers a variety of database engines options including MySQL, MariaDB, PostgreSQL, Amazon Aurora, Oracle, and SQL Server. Each engine is tailored to a specific needs from open source preferences to corporate environments. Now let's understand the features and options available in Amazon RDS. Let's dive into the key aspects you need to know. So when creating your RDS database, you have to select an instance to support your database from a processing and memory perspective. Plus consider multi-AZ for high availability and resiliency. Optimize your RDS database to meet the demands of your load with features like storage, auto-scaling, and scaling your compute size both vertically and horizontally. Amazon RDS take care of administrative tasks like patching and automated backup, providing an automatic backup feature and the ability to perform manual backup anytime you need to. So understand these features and options will make you the most of Amazon RDS for your database needs. So if you're trying to decide between Amazon RDS and EC2 for your relational database deployments in AWS, let's explore the benefits of each approach to help you make an informed decision. Amazon RDS or the Amazon Relational Database Service is an AWS managed service that simplifies the process of installing and provisioning relational databases in AWS Cloud. It supports popular open source and commercial database engines including MySQL, MariaDB, PostgreSQL, and even Oracle and Microsoft SQL Server. RDS also offers Amazon Aurora, a highly high performance, cost effective database solution. So RDS allows you to quickly spin up a new database without the need to install or configure any operating system or database software. AWS take care of administrative tasks such as backup, security, and high availability, making it ideal for smaller development shops or organizations without a dedicated database administrator. So in conclusion, Amazon RDS offers simplicity, cost effectiveness, and managed services, making it a compelling choice for many use cases. Now let's dive into various purchasing options available for database instances and associated costs. So you can purchase database instances to different payment plans, such as on-demand instances, reserved instances, and serverless. Each option is designed to help you save cost by selecting the most appropriate one for your deployment. Currently, only the Oracle database engine uses BYOL purchase options, while other DB engines utilize on-demand instances and reserved instances. Aurora also offers serverless as an additional purchasing option. So understanding these options can help you save a considerable amount of money based on your specific use case. So let's start by exploring on-demand instances which can be launched at any time and provisioned within minutes. So the cost of the compute capacity is calculated hourly on no minimum usage term. So the larger and the powerful the instance, the higher the cost. Any partial DB instance hours used are cost on per second increments. So it's essential to select the appropriate instance to support your database from a processing and memory perspective, as these will impact the instance price. So if you're trying to deploy your RDS database in AWS, let's explore the various options available. So you can choose to deploy your RDS database within a single availability zone or opt for a multi-AZ deployment to ensure high availability. Keep in mind a multi-AZ deployment will incur additional cost for a standby instance in another availability zone. If you are considering Amazon Aurora as your DB engine, you have the choice between Amazon Aurora with MySQL compatibility or Amazon Aurora with PostgreSQL compatibility, each with different pricing for on-demand instances. So another integrating option is Amazon Aurora Serverless, which eliminates the need to manage instance. Pricing is based on Aurora capacity units with each ACU charged at $0.07 per ACU hours in the London region. Consider the bring your own license option for Oracle, which allows you to use your pre-existing license. Additionally, reserved instances offer significant cost savings with reductions of up to 75% compared to on-demand instances. So with a range of deployment option and cost-saving strategies, deploying your RDS database in AWS can be tailored to your specific needs. Now let's dive in and explore the different options available about Amazon RDS storage types and pricing. Amazon RDS supports three main storage types, including general purpose SSD storage. This option is ideal for a wide range of use cases, offering low latencies and cost-effective solution with a minimum storage of 20 gigabytes and a maximum of 64 terabytes for most DB engines. It's a versatile choice. For workloads with high input-output operations, provisioned IOPS SSD storage is a great fit. You can provision a minimum of 8,000 IOPS and a maximum of 80,000 for most DB engines. The charges are based on the provisioned storage and IOPS throughput, ensuring flexibility for your specific workloads. Magnetic storage is mainly for backward compatibility, and AWS recommend selecting general purpose SSD instead. It's a simple and straightforward option for a specific use cases. So understanding the different RDS storage types and pricing can help you make informed decisions for your database needs. Whether it's general purpose SSD, provisioned IOPS, or magnetic storage, Amazon RDS offers a versatile solution tailored to your requirements. Now let's understand the cost of database backups. So when it comes to the backup storage cost for your database, there are few key points to consider. Firstly, Amazon RDS does not charge for backup storage that equates to the total sum of provisioned storage used within a specific region. Any storage used over these free tier is charged at $0.10 per gigabyte month for MySQL, PostgreSQL, MariaDB, Oracle, and SQL Server. For Aurora, the charge is different based on the region. Additionally, both automated backups and manual snapshots will use backup storage, and extended your backup retention periods will increase the storage required. It's important to note that backup storage is calculated based on the total amount of backups storage consumed within a specific region across all your RDS databases. If you copy your backup to another region, these will also increase the amount of backup storage used within the new region. Overall, backup storage for your RDS database is relatively simple to calculate and inexpensive, especially considering it is a free to backup 100% of your provisioned database storage. Now let's dive into the world of Amazon Aurora and Backtrack storage cost. Backtrack is a unique feature available for MySQL compatible Aurora databases, allowing you to go back in time on the database to recover from errors or incidents without the need for a full restore. During the database creation process, you can enable Backtrack via a simple checkbox and simplify the number of hours you would like to backtrack to, with a maximum of 72 hours. The number of changes made directly impacts the cost of the Backtrack feature. So for example, if you set 12-hour backtrack and your database generates 50,000 change records per hour, the total cost can be calculated based on the number of change records. So using the London region as an example, the cost would be $0.0084 per hour. To keep track of the number of change records, Amazon CloudWatch can help you monitor the changes generated each hour. So with the Amazon Aurora Backtrack feature, you have the power to recover from incidents with ease while keeping an eye on the associated costs. So if you're looking to perform in-depth analysis of your database data using specialized tools like Amazon Athena, exporting snapshots from your Amazon RDS to Amazon S3 might be a solution you need. Snapshots in RDS are essential backups of your database tables and instances. By exporting these snapshots to Amazon S3, you can leverage services like Amazon Athena, Amazon SageMaker, and Amazon EMR for detailed data and data analysis using standard SQL. When exporting a snapshot, you have the flexibility to filter and export specific databases, tables, or schemas. Keep in mind the cost of performing snapshot exports varies based on the region and the database type. So if you're ready to unlock full potential of your database data, consider exporting snapshot from Amazon RDS to Amazon S3 for a comprehensive analysis. Let's dive into the details of the different data paths where you might be charged for transferring data in and out of your RDS database. When it comes to data transfer, there are various scenarios where you might be charged. For instance, data transferred in and out of your RDS database from the internet to Amazon CloudFront or to different AWS regions. However, there are instances where you won't be charged for data transfer. These includes data transferred in from the internet out to Amazon CloudFront and to EC2 instances in the same availability zone. Data transfer out from your RDS database to the internet is charged per GB, with the first GB each month being free. The pricing is tied, becoming cheaper per GB as the amount of data transferred increases. Additionally, when copying snapshots across regions, you are charged based on the size of the snapshot at a rate of $0.0 per GB. Understanding the intricacies of data transfer cost is crucial for managing your RDS database efficiently. Stay informed to optimize your data transfer expenses. So in this part, we are diving into the key features and characteristics of Dynamo DB, a highly talked about database. Let's explore what makes it stand out. So DynamoDB is designed to be highly available by default, with data automatically replicated across 3 different availability zones within a geographic region. This ensures resiliency even in the case of an outage or incident, affecting an entire hosting facility. The database is also infinitely scalable and fast, supporting both eventual consistency and strong consistency based on your specific workload. This means you can choose whether you would prefer to use strong or eventual consistency with every read request to your database. However, DynamoDB supports transactions, ensuring atomicity, consistency, isolation, and durability. This is crucial for use cases like banking, where the reliability of operations is paramount. So whether it's a high availability, scalability, or support for transaction, DynamoDB offers a robust set of features that cater to a wide range of dataset database needs. Now let's dive into some key features and use cases. So to enhance your DynamoDB resiliency and performance. So DynamoDB offers global tables, allowing you to replicate data across regions for high resiliency and low latency access. With active replicas, you can write to any data table and read from the closest one. Perfect for multi-location use cases. DynamoDB provides on-demand backups for compliance and archiving, along with point-in-time recovery for going back to a specific database state. It also integrates with AWS Backup for centralized backup management. DynamoDB is infinitely scalable and fast, making it ideal for OLTP workloads, especially in serverless applications. It's commonly used in gaming, e-commerce, and transportation industries for various data storage needs. Whether it's for gaming, e-commerce, or transportation, DynamoDB is the to-go choice for a fully managed, infinitely scalable, and serverless OLTP database. So let's dive into a key differences between DynamoDB and relational databases. So relational databases scale vertically while DynamoDB scales horizontally, allowing it to scale almost infinitely. This means that DynamoDB scales transparently to the user, handling storage and compute scaling for you. So relational databases have a fixed schema, whereas DynamoDB is schemaless, allowing you to adjust columns and data types on the fly without defining a fixed table structure in advance. DynamoDB's built-in query and scan features aren't as flexible as SQL, but it does not support Particle, a SQL-like language for querying and modifying data. Additionally, DynamoDB has a limited range of data types compared to relational databases. So if you're already familiar with NoSQL databases like MongoDB, DynamoDB might feel more at home, but it's important to note that NoSQL databases vary within their own category. So DynamoDB has a strict limitation such as a maximum item size of 400 kilobytes, which may require storing large objects in a separate storage solutions like Amazon S3. If you're wondering how to interact with your DynamoDB table, there are four main ways to do. So let's dive into that details. So you can manage your DynamoDB tables through the AWS console where you can view, add and modify data with a graphical interface. Alternatively, you can script API calls using the AWS command line interface, providing a more hands-on approach. For a more customized approach, you can write code using the AWS SDKs available for various programming languages. Lastly, the NoSQL Workbench for DynamoDB offers a visual IDE tool for creating, managing, and querying your tables. So each method allows you to access the DynamoDB API organized as a set of operations for managing and manipulating your tables. Now let's dive into an overview of DynamoDB and DX. So Amazon DynamoDB is a fully managed NoSQL database service. It's designed to be highly available, fast and scalable. So with DynamoDB, you don't have to worry about the database administration or managing servers. So now let's talk about the DynamoDB Accelerator or DAX. So DAX is an in-memory cache that significantly enhances performance, offering response times in microseconds. So DX is highly scalable, capable of handling millions of requests per second. It also reduces the provision to read capacity within DynamoDB, ultimately reducing overall costs. From a security perspective, DAX supports encryption at rest and seamlessly integrates with your existing architecture without any redesign effort. So in summary, DAX provides extreme performance, scalability, and cost reduction, making it a powerful addition to DynamoDB. So introducing caching. So caching is a high-speed access data layer that stores frequently accessed data sets in memory, providing faster access velocity compared to traditional databases, queries, or disk access. So implementing a caching solution can significantly improve application performance, resiliency, and scalability, delivering at least 50 times faster access than disk access, reducing latencies from milliseconds to microseconds. So caching is crucial for read heavy workloads in social media, gaming, media sharing, news sites, and high performance computing, wherein memory access is essential for high speed data retrievals. Now let's discover the power of Amazon Elastic Cache, a web service designed to simplify the development and operation of an in-memory cache. It seamlessly integrates with Amazon EC2, Amazon RDS, CloudFormation, Elastic Beanstalk, and AWS OpsWorks, providing detailed monitoring metrics through Amazon CloudWatch. So by creating an in-memory data layer between applications and data stores, Amazon Elastic Cache accelerates read operation performance. It supports both mem-cached and Redis key value in-memory engines, offering a significant amount of automation for common administrative tasks. So while mem-cached is multi-threaded and designed as a caching solution without persistence, Redis supports complex datasets and includes disk persistency features. Elastic Cache for Redis also supports role-based access control and encryption, making it suitable for compliance standards like PCI DSS, HIPAA, and Fed RAMP. So Elastic Cache allows for the scaling in and out of nodes similar to EC2 autoscaling and includes auto discovery for new nodes and automatic node replacements in the event of a failure. This feature is applicable to memcached, while Redis can be deployed in a multi-AZ configuration with automatic failover. So Amazon Elastic Cache offers a powerful automated solution for managing in-memory caches, supporting both memcached and Redis engines with distinct features and benefits. So now let's dive into Amazon Neptune, the fast, reliable, secure, and fully managed graph database service. So the graph databases are designed to store and navigate relationships between highly connected data, making them ideal for identifying complex relationships of interconnected data. Amazon Neptune is recommended for scenarios like social networking, fraud detection, and recommendation engines where querying complex relationships is vital. So Amazon Neptune uses its own graph database engine and supports two graph query frameworks, Apache Tinkerpop Kremlin and World Wide Web Consortium SPARQL. An Amazon Neptune database cluster consists of single or multiple databases instances across different availability zones with a virtual database cluster volume containing the data. So each cluster maintains a separate copy of the shared volume in at least three different availability zones, ensuring high durability and reliability of data. So there are three types of Amazon Neptune endpoints: cluster endpoint, reader endpoint, and instance endpoint, each serving different purpose for connecting to the database. So welcome to a quick guide on understanding Amazon Redshift. So Amazon Redshift is a fast, fully managed petabyte scale data warehouse designed for high performance analysis of information. It's capable of storing and processing petabytes of data and provide access to these data using standard SQL. So a data warehouse consolidates data from multiple sources, allowing you to run business intelligence tools across your data to identify actionable business information. The need for performing an extract, transform, and load ETL job is crucial for combining data from multiple systems into a single database data store or a warehouse for storage or analytics. So Amazon Redshift is built upon clusters and nodes, with each cluster running its own Redshift engine and containing at least one database. The leader node coordinates communication between compute nodes and external applications. So Amazon Redshift boosts industry standard open database connectivity, Java database connectivity drivers for PostgreSQL, and is 3 times faster than other cloud data warehouses. Amazon Redshift offers features like massively parallel processing, columnar data storage, result caching, and integration with Amazon CloudWatch for monitoring performance. So now, welcome to Amazon Document DB lecture, where we will explore the features and architecture of these powerful database service. Amazon Document DB is a non-relational, fully managed service that highly scalable and fast. It's a document database allowing you to store JSON-like document data and query and index it easily. So this service allows you to scale both compute and storage separately, automatically increasing storage by 10G as your database grows after a maximum of 64 TB. Amazon Document DB is fully compatible with MongoDB, making it easy to migrate existing databases using the database migration service without modifying your code or toolsets. The architecture of Amazon Document DB is similar to Amazon Neptune with a core cluster component and up to 16 DB instances, supporting read and write operations and read replicas for high volume read requests. So the service uses endpoints for connectivity and performs automatic backups, allowing point in time recovery and defining backup windows for minimal impact on database service performance. Now let's welcome to the world of Amazon Key Spaces for Apache Cassandra, the ultimate solution for managing your databases in the cloud. So Apache Cassandra is a free, open source, distributed wide column store NoSQL database management system designed to handle large amounts of data across many commodity servers, providing high availability with no single point of failure. Amazon Key Spaces is a serverless, fully managed service designed to be highly scalable, highly available, and compatible with Apache Cassandra, allowing you to use all the same tools and code as you do with your existing Apache Cassandra databases. Boosting unlimited throughput, Amazon Key Spaces is designed for massive scale solutions, allowing you to service business critical workloads requiring thousands of requests per second. It offers extreme performance, scalability, and elasticity, growing at a rate of demand for your applications, ensuring you only pay for what you use. So using Amazon Key Spaces removes the need for you to manage infrastructure, allowing you to focus on the business logic of the database and your applications, ensuring you get the best performance possible. So Amazon Key Spaces is a perfect choice for applications where low latency is essential and for managing existing Cassandra databases in the cloud without the burden of maintaining your own infrastructure. Now let's dive into Amazon Quantum Ledger Database, where we will explore the features and use cases and integration of these innovative database service. So Amazon QLDB is a fully managed and serverless database service designed as a ledger database, ensuring the immutability and cryptography security of data. Unlike blockchain, QLDB is owned and managed by a central and trusted authority, eliminating the need for a consensus across a decentralized network. So QLDB is ideal for industries like insurance and human resources, providing an immutable framework for tackling extensive process and confidential data, ensuring accuracy and reliability. So the structure of a ledger database in QLDB is based on tables of Amazon Ion documents, maintaining an audit history of all changes through database transactions and cryptography verification. So QLDB uses journal storage to hold the history of changes and index storage for querying, both managed as a fully managed serverless service. QLDB streams allow capturing all changes made to the journal and feeding these information into an Amazon Kinesis data stream in near real time, enabling event-driven architectures and real-time data processing. So let's dive into data lake. A data lake is a centralized repository that allows you to store all your structured and unstructured data in its raw format. It's like a massive, unfiltered reservoir for all your business information. Having a data lake means you can gather data from various sources like transactional systems, IoT devices, mobile apps, and social media. These allows for comprehensive analytics and the potential for valuable insights through methods like machine learning. In today's data-driven world, managing and harnessing the power of your data is crucial. So creating a secure and organized space for all your data to reside is key. And that's where a data lake comes in. So if you're wondering what makes a good data lake, let's dive into the key components that makes a data lake effective. So first, let's talk about storage. The sheer volume of data can be overwhelming, but AWS offers a solution, S3. It's not only capable of handling large volumes of data, but also unstructured data like log files and binary output. Next, data movement is crucial. Whether it's streaming data with Kinesis, using a direct connection from on-premises, or utilizing the database migration service, automating the process is key. Once the data is in the lake, cataloging and understanding it is essential. AWS Glue provides a managed transform engine with a robust data catalog, making it easier to manage metadata and automate the process. Analyzing the data is where the real value lies. AWS offers services like Kinesis Data Analytics, Amazon Athena, Amazon QuickSight, and Redshift for different analytical needs. So lastly, predictive analytics is made possible through machine learning services like AWS SageMaker and deep learning AMIs, allowing you to gain insights into the future based on your data. If you're trying to build a data lake, let's explore how to do it with AWS Lake Formation. So there are two ways to create a data lake: manually assembling interconnected pieces or using AWS Lake Formation. The latter promises to set up a secure data lake in a matter of days. AWS Lake Formation identifies, crawls, catalogs, and prepares data from various sources like Amazon S3, relational databases, and NoSQL databases. It also handles log files from CloudTrail, Kinesis Firehouse, Elastic Load Balancers, and CloudFront. The services uses blueprints to manage data, allowing you to point to the source data, specifying the loading location, frequency, and customize the process. It also takes care of user security by creating self-service accesses and enforcing permissions across managed services. While AWS Lake Formation doesn't have additional pricing, users need to pay for services like AWS Glue usage, data residency within S3 and Athena queries. So if you're trying to build a data lake efficiently and securely, so consider AWS Lake Formation for a streamlined process.